Welcome to the third preparatory stage science course. I am Rania Hasabo and I am going to be your teacher here during this course. The goal of this work is not only for the exam, but also for understanding and linking information to the life around you. Wish you all the best of luck. Now let's start.
Hello my lovely students. Today we have a new lesson. But firstly, observe the opposite pictures, then mention the basic structure in all these optical tools, which are used for different purposes. Of course, it is a lens. Yes, our lesson today is called the lenses. There is a great similarity and also differences between lenses and the mirror. But now, let's start to know what's meant by lenses. It is a transparent media that refracts, not reflects. Yes, it is a transparent media that refracts the light and limited with two spherical surfaces. Refraction of light. Deviation of light when transmit from a transparent medium to another of different optical density. Most of light can travel in transparent media as in air, water, plastic, glass. Air, water, plastic, and the glass are considered as a transparent media, but they are different in optical density. To explain the refraction in simple way, not all the fact, simple way to know what's meant by the refraction. Why light refracts when travel from air to water? The particles of air are very far from each other, so the light travels through them easily. البارتكلز بعيدة عن بعض فاللايت بيقدر يتحكم وبيقدر يمشي فيها بسهولة. While in water the medium particles are close to each other, فبتبدأ تضايق اللايت وهو بيحصل له travel through them. فبيحصل بيحصل decrease للspeed of light in water، وهو ده بيكون a reason of a light refraction or deviation. So we can say that this is wooden tank depressor appears broken due to light refraction. Finally, the speed of light changes according to the optical density of medium. When light travels in air, it moves in a straight line, while when it passes from air to water, from transparent media to another, from air to water, its speed changes, which causes the deviation of light, so the object seems broken. The speed of light in air always greater than its speed in any transparent media. In this lesson, we will study the uses of lenses. Firstly, we use lens in medical glasses for reading and walking. He is my favorite actor. Okay. The second one in magnifying pieces to see the tiny objects. For example, it's used for fixing watches. The third one is binocular to see the very far objects. Number 4 in making telescope and microscope. Telescope used to form a magnified image for celestial bodies as sun, stars, while microscope used to form a magnified image for tiny bodies. So, the two tools used to form a magnified image, but telescope for celestial bodies as stars, while microscope for tiny bodies as bacteria. Types of lenses. Lenses have many types, not only two. Among them, concave and convex. So, lenses have many types, but we will study only two, concave and convex. Firstly, remember with me what's meant by lens. It is a transparent media, refracts the light, and limited with two spherical surfaces. Limited with two spherical surfaces as the lens is formed from two spheres. The first one, concave, formed by filling the space between the two surfaces. So finally its shape seen at its center and thick at the tips. While convex lens formed from the intersection between the two spheres. So finally it is thick at its center and thin at the tips. Yes, we will study two types only of lens, concave and convex. Concave lens separates light rays falling on it, while convex lens, it collects light rays falling on it. So,
Concave lens is called the diverging lens, while convex lens is called the converging lens. Special concepts related to the lenses. Number 1, center of curvature. Remember with me, lens means a transparent media refract light and limited with two spherical surfaces. Limited with two spherical surfaces, as each surface is a part of a sphere. It has two surfaces, so it has two center of curvature. Center of curvature, it is the center of the sphere where this face is a part of it. And we have a special or a very important point which is called the optical center of lens. It is the point inside the lens, placed on the principal axis in the middle distance between the two faces. Again, it is a point inside the lens, okay, on the principal axis, at the mid distance between the two faces. In case of spherical mirrors, mirror has only one center of curvature, as its reflecting surface is a part of hollow one sphere, so it has only one center of curvature. But in lens has two center of curvature and has two faces because it has two spherical surfaces. Lens part of two spheres while mirror part of one sphere. Radius of curvature, it is the radius of the sphere where this face is a part of it. As the lens is limited with two spherical faces, so each face has its own radius. And radius, as usual, is half the diameter of the spheres. Okay, then we have very important point inside the lens. Point inside the lens on the principal axis between the two faces. Optical center. The straight line which passes by optical center may be principal axis or secondary axis. To differentiate between them, principal axis, it is the straight line passes by the optical center of the lens and joins between the two center of curvatures. While the secondary axis, it is any line passes by optical center only, but not passes by the two center of curvature. So, principal axis, it is the straight line that join between the two center of curvature of the lens, passing by the optical center of the lens. While secondary axis, it is any line passes by optical center of the lens except the principal axis. So normally, lens has only one principal axis, as the principal axis is the straight line passes by optical center, but must be passes by the two center of curvature. And any lens has uncountable number of secondary axes, as the secondary axis, any straight line passes by optical center only, but not passes by the two center of curvature. Principal focus. It is produced when a beam of light rays falls parallel to the principal axis. We have two definitions of focus. In case of convex lens, it is the point of collection of refracted light rays, while in concave, as it is a diverging lens, it is the point of collection of extension of refracted light rays. So we have two types of focus: real focus in case of convex lens and virtual focus in case of concave lens. Any lens limited with two spherical faces, so has two center of curvature and has two focuses, two foci. While the distance between the focus, the principal focus, and the optical center of the lens, the point inside the lens, the distance between focus and the optical center is called focal length. The size of lens. It changes according to the convexity of its face. If the convexity is large, the focus is nearer to the optical center, so the lens has a small focal length. While if the convexity is small, the focus is farther to optical center and the lens has large focal length. Finally, the thinner of the lens is larger focal length. The thinner of the lens is larger focal length.
Rules for determining the direction of light rays after passing through the convex lens. The first ray falls parallel to principal axis. It refracts passing through the principal focus. While if the light ray passing through the focus strikes the lens passing through the focus, it refracts parallel to principal axis. So parallel focus and focus parallel as in mirror. While if the light ray passing through the optical center, very important point and a new point inside the lens. If the light ray fall passing through the optical center of the lens, it doesn't refract, and passing in a straight line passes without any refraction.